Greetings and welcome back. In this video, we are going to create a basic Sprite emitter. So just kind of a simple system that looks like some sparks, just to kind of get things started and get your feet wet. The first thing I want you to do to keep things kind of organized is let's create a new folder. So we'll create this right here inside the content browser under the game folder, and I'll call this My Particle Systems, like so. And I'll open this up, and the first thing I'm going to do in here is make another folder, and we will call this Sprite. So that'll be what this is for a Sprite emitter. Now, like many particle systems that you will create, a particle system is going to be part material and part particle effect. I don't want to spend a ton of time on the material side of things, but we do need to keep it in mind. So let's do that. I'm going to create a new material for starters, and I'll show you how to make a really basic material that's good for things like sparks and whatnot. We'll call this mat_sparks. Double click and open this up, and I'll bring the material editor over, make it nice and big. Okay, first things first, this does not need to be an opaque surface. We're going to make it translucent, and we're going to take the shading model and set it to unlit. Now that means we only really worry about emissive color and opacity. Now for a spark, all I want is just a fuzzy circle of some color. I can define the color in the particle system, and we'll stretch the thing out to make our spark a little bit later. So this will be really simple. Let's right click and we'll make a radial gradient exponential. We're not going to change too much about this actually. We could just plug this right into emissive color and opacity, and if we preview this on a flat plane, you can see what that looks like. So that's actually pretty good, but we're going to make it better, make it a little more useful for a particle system by adding a particle color node. And what this is going to do is take in inputs from a particle system and use whatever colors we feed in the particle system to drive the material. So let's take the RGB data, and we will, I wish I could type, multiply that by the radial gradient, and we'll plug that into emissive color. And then we'll take the alpha and multiply that again. I should just hit M and click, it's much faster. And we'll drive that into opacity. That's really all we need to do for this material to work. So we'll go ahead and apply, and we'll save, and we're done here. We can just go ahead and close this out. Now we're going to create our particle system, so we'll right click and create new particle system, and we'll call this P_sparks. Double click and open it up, and here we are inside of Cascade. Now we have our default material on these right now, the little crosshair sort of thing. I'm going to select our required module. The required module is always going to be there. You can't get rid of it. But that's what contains your material. So we're going to select that, and we'll go under material, and let's find mat_sparks. Oh, there it is. We'll drop that in, give that just a second to get going, and boom, there we go. You can see our little circles kind of doing their thing there. Now there's all kinds of fun stuff to be aware of in the required module, right? So we have some controls for the emitter, like in this case we've changed the material. There's things like use local space, which means if we were to rotate the emitter, then the particles would move in the direction of the rotation, or like if we were to move the particle system around the level, the particles would just move as if they were parented to the emitter. We have things like, if we scroll down a little bit, we have duration, so how long this emitter is actually going to work. We have things like delay or sub-UV. We're going to talk about sub-UVs a little bit later. It's useful for things like fire and smoke or anything powered by a flipbook. Anyway, what we're going to do though is take the screen alignment, and this is how the particles are rotated as they face the camera, and we're going to set this to velocity. That means they are going to rotate in the direction that they are moving, which is very useful for us. Because our next thing is we're going to take the initial size of our particles and we're going to pull them way down. Now, it can be a little tricky here inside the preview window, here in Cascade, to know how big your particles are, or really a lot of things like what they look like, what their movement is really doing in the real world. So it's very useful to early on take your particle system and just drag it into your level so that you can get an idea of what things really look like. And just be sure to check that early and check it often. Now let's take our initial size module and we're going to change this. So right now it's 25, which is pretty big. Let's go with a max of, I don't know, let's try a 4 for the maximum and something like 2 for the minimum. And that'll give us a little bit of a random range. And I think that's working fairly well. Let's also, I guess we can leave them emitting from a single point. If we wanted to spread them out so they emitted from more than just a single point, we could right click and go under location and we could say initial location. Now I like my initial stuff to be up near the top, so I generally move that up. It doesn't really change anything. It doesn't make anything behave differently. It just makes me feel better to have all my initial settings kind of up toward the top and then all my over life stuff happen afterward. So let's take initial location and we can, let's see, the distribution has currently got a min max, so that's kind of cool. We could say, let's say negative 20 for the min. Oh, let me get my negative sign in there. So negative 20 and negative 20, and then max will be 20 by 20 by 20. So there we go. So now it's kind of spread out a little bit all over the place, as you can see. And if we take a look over in the level, you see what that looks like. Now these guys are a little bit hard to see right now, but we're not worried about that just yet. Okay, so initial velocity. This is the direction these things are going to be traveling the moment that they are born. Right now, they're primarily being pushed upward. What I'd like to do is push them in the x direction. So let's take x and we'll set that to like 200 with a minimum value of, say, 100. That'll give us some nice variation. And then for z, let's even that back out. In fact, let's change y and z a little bit. Let's do something like 20 by 20 and then negative 20 and negative 20. So we got a lot of variation, but generally speaking, we're just pushing out in the x-axis, which you can see here. It's starting to look kind of like snow being blown out, isn't it? Now, a few things we can change. I'm going to kind of make use of my screen as much as I can. Let's go ahead and maybe take this panel and slide it over, and I'll keep Cascade kind of, actually we could probably just Windows right and tack Cascade over here to the right-hand side. We're only going to be using one emitter here, so for now we can do something like this. So now we can kind of see it in the level while we work, which is pretty cool. Also, I'm going to rotate my view around to the other side, simply because if I don't, it looks like the particles are going in two different directions, and that confuses me and therefore irritates me, so we won't do that. Let's take our lifetime module, and I'm going to change the lifetime of my particles. Let's do, they need to live longer than they are. Let's say maybe 4 seconds on the min and 5 seconds on the max. Ooh, just a quick pro tip for those who are keeping score. Make sure you stay aware of the order in which min and max are listed. It is a known thing that back in the days of Unreal Engine 3, max, which is first in alphabetical order, would often be listed before min, but sometimes it's swapped around. Like here, check it out. Initial velocity, it's max, then min. In lifetime, it's min, then max. I'm not saying I'm super happy about that. That's fine. That's gives us things to improve in the future, but I want you to be aware of it so that you don't accidentally trip over it. Okay, so let's see. We have lifetime living between 4 and 5 seconds now. You can see those particles they're moving on to the next area. I feel like they could be bigger, but I don't want to jump onto that bus just yet. Let's change and make them kind of stretch out. Actually, let's make them fall first. I feel like they need to fall. You'll see as you start to work with particles that once you kind of know what you want, I mean, in this case, I want sparks that kind of fall down and bounce to the ground. The order in which you add things is really kind of up to you. So let's go to acceleration. We'll do a constant acceleration. And let's see, in Z, we'll do something like, I think negative 980 would be gravity. And that's a little extreme for what I had in mind, but it's really not bad. Pull this back over. I feel like we could just use a lot more particles now. So let's take spawn and we will kick it up to, say, 300? Oh, there's a lot more particles, but that's way too many. So let's go to maybe 50. So there we go. It's still pretty thick, but not really overdoing it. Now let's make them stretch out the way sparks do. Or do you think we should change the color first? Let's maybe do the color. Nah, that could be good. Now for this, I'm going to make Cascade nice and big so that you can see the curve editor, because that's going to be really important for this next part. So we're going to take the color over life module, which came in on its own by default, and we're going to jam that into the curve editor. Now, we have two sets of curves here. We have the alpha over life curve. That's a scalar value, so that only has one curve. And then we have the color over life. That is a vector, R, G, and B data, so that's going to be 3 curves all in one. Let's say I'm not too worried about alpha right now. I'll change that in a minute. So for now, what I'll do is I'll turn that off by clicking on the little yellow box at the end of the tab for it. And then for color over life, we have the numerical data. What I will often do is start off by adding in the number data first, and then I'll just tweak things and clean it up a little bit in the curves. And that's just a personal preference. If you want to start over here just by control clicking and adding keys that way, you can certainly do that. That's completely your prerogative. But for now, let's see. It's important to know how these values work inside of a curve if you're editing it numerically. So you really are down to the in val and the out val. I do not recommend you edit tangents using the numbers if you don't have to, because you'll find editing tangents is a lot easier in the curve editor. You have a visual representation of what that tangent is doing, unless you're just a whole lot better at vector math than I am, and if you are, then I applaud you. So your in value represents where you are in time. Your out value represents the actual value given to the key at that given point. So here you'd say like 0 in val means we're at the moment the particle's born. The out value would be the color that the particle has the moment that it's born. And then for 0.1, our out value is 1, or the moment the particle dies, and out value is what color it's going to be at death, essentially. So let's see, let's set the color at birth to something really bright, intense red. Remember, we're driving emissive color, so we can really push this value. We can do like 30 for red, and then something like, oh, I don't know, 3 for green and 1 for blue, and we start to get something that's super red. Maybe something like 10, there we go. So if we go 10 for green, we start to get something that's pretty orangey and still glowing pretty heavily. And if we take a look, you can see those starting to come out, which is pretty cool. And for the moment of death, right now everything's fading back to white. I don't really care for that at all. Let's go ahead and leave it the same color. As a matter of fact, if you know you're going to be doing the same color, you could just make this a constant. But just to show off, I guess, a little bit, let's say we change the color of our sparks as they fall. We'll take red and leave it at 1. We'll take green and we'll set this to, I don't know, something like 5. And then we'll kick blue way up to, say, about 25. And now the particles, as they fall, they shift between white and then eventually to blue, but to really see that we need to shorten the lifetime considerably. So let's do something like just 1 to 2 seconds of life. And now you can see those particles starting to turn blue as they fall, which is kind of nifty, but I'd like to see it just be a little bit more ostentatious. So let's do maybe 40 on the blue, and then maybe something like 20 on green, and then they'll start to become more of a teal color, which I feel like is just going to jump out at folks a little bit more. Also, I'm not seeing these enough. I know that when they start to streak out, which is something I haven't set in yet, that's going to change that a little bit, but my gut tells me I should just take my initial size and kick it up a little bit. So let's go with a max of about 6. And I really only need to worry about the first number. I can just lock the axes, but out of habit, I'm changing everything. There we go. So those are much bigger. And now you can really see those sparks starting to fall, which is pretty nifty. Let's pull our lifetime down just a little bit more for the sake of example. So everything lives for exactly 1 second, and now you can really see that color shift starting to take place. Now let's add that stretching behavior where the particles actually stretch out in the direction that they're moving. This is done by going into our emitter, right click, and we're going to add a size module. And you see there's size by speed. Now, this is 2 settings you need to be aware of. You have speed scale and you have max scale. We're going to change the size in Y. So if we set that up to 1, actually we want to crank it pretty far. Let's set it to maybe 3. We're not going to get that much of a change until we increase the max scale as well. So max scale kind of works like a cap. And by doing that, you can see that our particles are now starting to stretch out. We could go a little bit higher, maybe something like 6. Oh, there we go. And now they're really starting to fall. However, now that the particles themselves are larger, you'll probably want to go back and do some tweaks. Like that color is really, really bright. Probably doesn't need to be that bright. So we could maybe pull this down. Instead of 30, 10, 1, we could do maybe 20 and 7 and 1, and then maybe for the blue, we'll pull that down to about 10 and 20, so we'll cut that in half. So just kicking back some of that intensity. Also, our initial location, I think I kind of want this to be a little bit more from a singular point, but instead of making it just one point, I'll just tighten this up a little bit. We'll go 5 and -5. And there we go. So that's working pretty well. Now the next thing I want to do is have these particles collide when they hit the ground, because right now they're just passing right through the ground, which is nifty, but not what I want. So let's right click and you'll see under collision, which is up near the top, thanks alphabetical order, we can add collision. And this automatically stops the particles. So I mean, they're hitting the ground and then they're just dying. They're not passing through anymore, but we need to change that collision behavior a little bit. First off, we want to come in here to the settings, and I'll go ahead and make this a little bit bigger so everybody can see it. We're going to take the max collisions, which is the maximum number of collisions allowed, and we're going to set that somewhere between 2 and 3. And so now they're colliding, and then we have a collision behavior. Basically, what happens after we've collided the maximum number of times we can? Well, we kill the particle. That's all well and good, but we are not getting any sort of bounce from that collision. That's controlled in the damping factor. Now, damping factor is kind of how much of the energy you're going to retain on each bounce, and right now that's set to 0, which is not particularly useful to us. So we're going to take that and set it to, let's say, a maximum of, I don't know, maybe 0.3 and a minimum of 0.1. And there you go, you're getting a little bit of bounce right there at the end. So it's just showing off some different behaviors. All right, so with that, we have created our first little particle effect. It's not, it's not going to win any sort of effects awards, but it does get your feet wet. You created an emitter, you created some different modules, and you edited a bunch of settings. You got it tested in the level. And really the last thing we could do to kind of make things kind of nice is, let's come in here to Cascade. Let's line up a representative shot here in the viewport, and then we'll just click on the thumbnail button. So that now here in the content browser, we have a thumbnail that actually looks like our particle system. So what I want to do is show you how to make this particle system emit light. It's a single module and it's pretty cool, but if you haven't seen it or don't know it's there, then, well, you don't know what you don't know. So I'm going to open the particle system back up and we'll bring it back over here front and center. And let's say I want these sparks to illuminate my scene in some way. I can just right click, and since this is a standard particle system, it doesn't have an extra type data module, I can just go down to light and add a light module. And if we take a look at this in the level, the thing is now adding light. And the light is actually a little bit on the intense side, so let's make some changes to it, kind of tweak that a little bit. The inverse squared fall off bit I like. It doesn't need to affect translucency. It can keep things a lot simpler there. It does not need to spawn 100% of the time, meaning that every single particle does not need its own light. This will still look just as good without quite so many lights. So we can set that down to 0.2, and now only 20% of these things are actually emitting light. You see it still looks really nice. We could take the radius and maybe we can tweak it, kick it up a little bit. We can also take the brightness and maybe pull it down slightly. But you'll see that light is just automatically inheriting the color that we applied to our particle. So that will wrap things up for this video. Thanks a lot.